Funding for this video has generously been provided by the Danzger Institute of Statistics and Danzger Designs, capturing some of life's most precious moments at an affordable price. Coming up next on 60 Minutes, or should I say 60 Seconds, the latest study produced by the Danzger Institute of Statistics. Back to you, Scott.
I'm Scott Pelley. Those stories and Andy Rooney tonight on 60 Minutes.
Hi, my name is Ben Danzger, and I'm an executive director at the Danzger Institute of Statistics. In our latest study, we set out to determine how THS students perceive time. We know that THS students lead active and busy lives, and we wanted to find out how that affected their perception of time.
Hi, I'm George Abrasaglu, and I'm another executive here at DIAS. We made sure we got a diverse group of students by covering all grades, genders, and even stress levels. We also made sure to gather a sample that was less than 10% of the entire THS population.
Our researchers surveyed 78 THS students during 4 periods of the day, 2 in the morning and 2 in the afternoon. We handed each a stopwatch and instructed them to stop it after they thought a minute passed, without counting in their heads and without looking at the watch.
So here's how we actually conducted the study. We told the subject to hold the watch facing the recorder like this, and we tell them to start it and to not count in their head or look at the watch. And we would tell them also to stop whenever they thought it reached 60 seconds. So here I go, click the start button, and whenever the person would think that it reached 60 seconds, they click the same button again to stop.
We made sure that our researchers didn't look like they were waiting on the participants so that they wouldn't feel rushed to stop the clock. To make sure that our subjects were independent of each other, we targeted people who were studying or just sitting down individually. We thought that if we conducted the survey amongst a group of people, that the second person would see how the first person fared and try to adjust their time to get closer to 60 seconds. So we tried to eliminate this competitive factor.
Ah, 56 seconds and 75. 56.75 seconds, not too bad. Just about 3.25 seconds off the null hypothesis.
We introduced randomization by taking 19 or 20 students from 4 different periods. In this way, we used stratification.
To reduce bias, we took samples from 2 morning periods and 2 afternoon periods in case that time of day was a factor. We tried to survey from different genders, different grades. We made sure we had freshmen, sophomores, juniors, and seniors, and both male and females from each grade.
We found a mean of 54.87 seconds compared to the 60 seconds of a minute, with a standard deviation of 14.13 seconds. Here you can see a histogram of our results. There's a center at 55, and it's for the most part unimodal. There's a slight skew to the left, which we anticipated because not many people go too far over a minute, but a lot of people get very short times. For instance, we had an outlier of 14.7 seconds.
The black bars represent the upper and lower bounds for 2 key outliers, which are 1.5 standard deviations above and below the mean.
Here you can see a box plot of our results. The same center around 55 and a slight skew to the left. And here you can see the outlier of 14.7.
The graph, courtesy of Minitab, shows the outliers in a different way. The upper and lower bounds are more extended, which means that some of Tukey's outliers are excluded. Besides gender and age, we chose to include personal stress level as a variable. We hypothesized that those who, compared to previous experiences with stress, felt more pressure would stop the clock short, as they live very fast-paced lives. Here's a scatter plot which graphs stress level against the residuals. We hypothesized that there would be a negative correlation because stress likely causes people to live more fast-paced lives. There's clearly a negative correlation, however it's not very strong. The R-squared is only 0.02984, which means only about 3% of the data is accurately predicted by the regression line. Some notable outliers are the one at a stress level of 1, who stopped the clock about 30 seconds short, and a group of people with stress levels around 6 and 7 that also stopped the clock very short. On the top, you can see the equation for the regression line.
We chose a null hypothesis of 60 seconds, assuming that the average THS student would stop the clock at exactly 60 seconds. Our alternative hypothesis was that the mean that we got from our sample would not be 60 seconds. Because of the nature of our data, null hypothesis of just flat 60 seconds, we were able to easily do a test, one sample t-test, and from that we used a degrees of freedom of 77, which is the sample size minus 1. We had a sample size of 78.
We used an estimated standard deviation for the entire population, which came out to 1.6. Then we plugged that in to find the t-score for our data. We found a p-value of 0.002, and because we wanted to see if there was a difference from the null hypothesis, we doubled the p-value to get a two-tailed t-test, and thus we got a p-value of 0.004, which means that there's a 0.4% chance that we'll see this mean of 54.87 with our sample size of 78, assuming that the null hypothesis of 60 seconds is correct.
Thus, we had enough evidence to reject the null hypothesis, and it is clear that THS students think a minute is shorter than it actually is.
As you know, when trying to conduct a study, there are always lurking variables and caveats. In our case, we try to conduct our study in the middle of the library during a school day, which means that some students that we asked might have wanted to just get the study over with, get the experiment over with, and just click the button faster. So we made sure that we'd ask each student before the study whether or not they had a few minutes to spare.